Hi guys, let's do section 3 of chapter 6, water and solutions. Our 3 essential questions: how does the structure of water make it a good solvent? What are the similarities and differences between solutions and suspensions? And what are the differences between acids and bases? Here is the vocabulary. Hopefully you remember a lot of these words from last year, or at the very least you've heard of them from maybe middle school science. So hopefully you are familiar with those and have those written somewhere in your notebook because they will be on the next notebook check. Water's polarity. Water molecules are formed by a covalent bond. Remember, a covalent bond is one where 2 atoms share electrons. So water molecules are formed by a covalent bond that links 2 hydrogen atoms and 1 oxygen. Now the water molecule is greedy and it pulls more of the electrons toward it. Okay, it shares them unequally. So the hydrogen atoms have a slightly positive charge. They don't have as much of the electrons. The electrons are further away from them. And the oxygen has a slightly negative charge. Molecules that have an uneven distribution of charge are called polar molecules, meaning they have oppositely charged regions. So here, at this end and this end, where the hydrogen atoms are, is slightly positive. Over here, the other side, where the water is slightly negative. When a charged region of a polar molecule comes close to the oppositely charged region of another polar molecule, a weak attraction is formed. If one of those atoms is a hydrogen atom, it forms what's called a hydrogen bond, which is a weak interaction involving a hydrogen atom and a fluorine, oxygen, or nitrogen atom. A hydrogen bond is a strong type of a van der Waals force. A mixture. A mixture is a combination of 2 or more substances in which each substance retains its individual characteristics and properties. Mixtures are either homogeneous and heterogeneous. Homogeneous meaning that they are the same throughout. Milk is homogenized. It goes through a process that makes it the same throughout. Heterogeneous means different throughout, so this would be like a fruit salad or a stew, something that you can see distinct regions that are different. Homogeneous mixtures. When a mixture has a uniform composition throughout, it is called homogeneous. A solution is another name for a homogeneous mixture, or homogeneous. In a solution, there are 2 components. There's the solvent, that is the substance that is being dissolved, that is doing the dissolving, and the solute, the substance that is being dissolved. So the solvent is usually a liquid. Usually, not always. The solute is usually a solid. So if I made a coffee solution, water is the solvent, the solute is the coffee particles. The same thing with salt water. If I were to make salt water, the solvent would be water and the solute would be salt. Heterogeneous mixtures. When the components in a mixture remain distinct, it is a heterogeneous mixture. A suspension is a type of heterogeneous mixture where the particles settle out over time. A colloid is a heterogeneous mixture that do not settle out. So this would be like a bottle of glue. A colloid, the particles don't settle out. Doesn't matter how long I let this bottle of Elmer's glue sit on my desk, it's never going to settle out. Acids and bases. Many solutes readily dissolve in water because of its polarity. Substances that release hydrogen ions when they are dissolved are called acids, and substances that release hydroxide ions, which are OH- when they are dissolved, are called bases. pH and buffers. The amount of hydrogen or hydroxide ions in a solution determines the strength of that acid or base. The measure of concentration in hydrogen ions in a solution is called pH. Acids have a pH value of less than 7, and bases have a pH value of greater than 7. Buffers are mixtures that can react with acids or bases to help keep the pH within a particular range. We have a lot of buffers inside our bodies because it's important for us to maintain a particular pH so that enzymes can work properly. If the enzymes aren't working properly, then we're not getting the chemical reactions done that need to be done, and it could be really bad for the organism. And that's it, guys. So if you have any questions, let me know.